we present the first approach towards panorama light field imaging. We capture overlapping sublight fields of a scene during a cylindrical or spherical camera motion and convert each sublight field into a focal stack using conventional synthetic aperture reconstruction. For light field cameras that directly deliver a focal stack, this step is not necessary. Next, we compute an all-in-focus image for each focal stack by extracting and composing the highest frequency image content throughout all focal stack slices. The registration and blending parameters are then computed for the resulting overlapping all-in-focus images. For this, we apply conventional panorama stitching techniques such as surf feature extraction, pairwise feature matching and Ransec outlier detection, bundle adjustment, wave correction, exposure compensation, and the computation of blending seams. The registration and blending parameters that were derived for the all-in-focus images are now applied to all corresponding slices of the focal stacks. We use a four-dimensional motion model for registration and multiband blending for composition. The result is a registered and seamlessly blended panorama focal stack that can be converted to a light field with linear view synthesis. The light field that you see here has a spatial resolution of 22 megapixels. Since we chose an intermediate focal stack representation, common image panorama techniques can be applied for robustly computing a panorama light field without a precise reconstruction of scene depth. However, the focal stack of a scene covers no more than a 3D subset of the full 4D light field. This limits our current approach to Lambertian scenes with modest depth discontinuities. In future, we will investigate panorama light field imaging techniques that are applicable directly to the 4D ray space. With increasing resolution of imaging sensors, light field photography is now becoming increasingly practical, and first light field cameras are already commercially available. Panorama imaging techniques already became an integral part of digital photography, often being supported by camera hardware today. Here we present the first approach towards panorama light field imaging.